Okay, so thank you so much for joining this My Scratch lecture. And based on some of your requests, I have recorded this lecture. And in this lecture, we speak about how to write formulas for compounds. And the way we start with this is starting with the binary ionic compounds. And the word binary means two, right? And ionic compounds means gaining and losing electrons. So the first thing I need to understand when I name a binary ionic compound is to try to find what are the elements that are participating in this compound. Like for example, if I have sodium chloride, then the two elements or the two atoms are sodium and the chlorine. Now the next thing that I need to know is something called the oxidation number, And what is the oxidation number? It is the number of electrons that need to be gained or lost for the compound to become stable. So let me give you an example. If we speak about sodium chloride, for example, it's NaCl. Sodium belongs to group number 1. So it has one electron at the outermost orbit, and it needs to lose this one electron to become stable, right? So the oxidation number of the sodium is 1 plus. Now the same thing for the chlorine. The chlorine belongs to group number 17, so it has 7 electrons at the outermost orbit, and it needs 1 electron to become stable, so the oxidation number here is 1 minus. So by memorizing the numbers at the top of this table, the periodic table, you can tell what is the oxidation number or the oxidation numbers of different elements. So for example, I have all the elements in group number 1, oxidation number is 1 plus, group number 2 is 2 plus, group number 3 is 3 plus, and 13 is 3 plus, 14 is 4 plus or 4 minus, 15 is 3 minus, 16 is 2 minus, 17 is 1 minus, and 18 is 0. So what does that mean? It means that all elements in group number 1 needs to give away 1 electron to become stable, and all elements in group number 2 needs to give away 2 electrons to become stable, 3 needs to give away 3 electrons, 13. 14 can give or lose 4 electrons, 15 is to gain 3 electrons, 16 is to gain 2 electrons, 17 1 electron, and of course 18 are the noble gases. They don't gain or lose any electrons. So what about the groups from 12 to 13? And these are what we call the special ions, and they also have their own oxidation number, but they could have more than one oxidation number. Like for example, the copper could have 1 plus or 2 plus, the iron could be 2 plus or 3 plus, the chromium 2 plus or 3 plus, and the lead 2 plus or 4 plus. Now that depends on what? It depends on the other element that it interacts with. So far what we are saying is in the periodic table, groups 1, 2, 13 through 18, they have only one fixed oxidation number, either plus or minus. And for those special ions from 3 to 13, from 3 to 12, they could have more than one oxidation number. Now, I'll explain this point later on, but let me give you some example on how to name those oxidation or those binary ionic compounds. So look at this. Now we have one compound which is called the calcium fluoride. That is a binary ionic compound. Now why it's binary? Because it has 2 elements. Why it's ionic? Because it's gaining and losing. Because here that obviously the calcium loses 2 electrons and the fluorine gains the electrons, right? And now I want to name the calcium fluoride. I want to write what is the chemical formula for the calcium fluoride. So now let me show you how can we do this, how we write the chemical formula for the calcium fluoride. So what the thing that I will do is, first thing I see what are the elements that are participating here. So I see the calcium and the fluorine. So I'll just say Ca and F. Then I need to think about what are the oxidation number of these two elements. So for the calcium, if I go back to the previous table, you will find that the oxidation number is 2 plus because it belongs to group number 2 in the periodic table. And for the fluorine, it is 1 minus. Okay, so now I know what are the oxidation numbers. Then the last step is I just need to switch these two numbers. So the 2 will go with the F and the 1 will go with the Ca. So it becomes CaF2. Now remember, you do not write the negative and you do not write the 1. So it becomes CaF2. So that means that the calcium loses 2 electrons, and one of them will go to the first fluorine, the other one will go to the second fluorine, and that makes sense, right? Because the fluorine belongs to group number 17 in the periodic table, and it needs 1 electron to become stable. Okay, perfect. Now what if I want to do the opposite? What if I want to start with the CaF2 and I want to know what is the chemical name of the calcium fluoride? So in that case, what I will do is I will start with this. I'm starting with the CF2 and I want to write this name. So in this case, what you need to do is you need to say, okay, you have 2 elements. One of them is the calcium and the other one is the fluorine. So that's a calcium and the other one is the fluorine. But when fluorine participate in a compound with the calcium, we don't call it fluorine. We don't call it fluorine, but we call it fluoride. Okay, so it becomes the fluoride. So I need to add this IDE ending at the end of the element. So for example, oxygen becomes oxide, and nitrogen becomes nitride, and sulfur becomes sulfide, right? So I have to add this IDE. Okay, now there's an important question here. Now, why I put calcium first and fluoride second? And the idea here is you always put the positive oxidation number first and the negative oxidation number second. So it becomes calcium fluoride. Okay, so now we have learned 2 things. We have learned how we can start from the chemical name calcium fluoride and get the chemical formula CaF2, or I start with the chemical formula CF2 and get the chemical name. Now let's try to apply this to the special ions with more than one oxidation number. Now let's say that I have a compound that is called Fe2O3 that contains iron and oxygen, and I want to write what is the chemical name of that compound. So in this case, I need to write iron because it's the first one and it has a positive oxidation number, and then I write oxide. Remember, I don't write oxygen, I write oxide. I have to use this IDE endings because it is now participating in a compound. Now I have to look here at the iron, and you can see that iron can have oxidation number of 2 plus or 3 plus. So which one is being used in this compound? Is it the 2 plus or is it the 3 plus? Now let's think about it. Now if you look here at this compound, you see that the oxygen belongs to group number 16, so it has 6 electrons at the outermost orbit. So it needs 2 electrons to become stable, right? So if it needs 2 electrons to become stable, and I have 3 of those oxygen, then I need to have 6 electrons, right? So again, oxygen belongs to group number 16, and it needs 2 electrons to become stable because it has 6 electrons at the outermost, right? Now I have 3 of those oxygen, then I need 6 electrons. Now where do they come from? They come from the iron, right? Now I have only 2 atoms of the iron, so they have to provide 6 electrons, so each one needs to provide 3 electrons. So it must be the 3 plus, okay? So it must be the 3 plus, right? So when I write the name of that compound, I will write iron 3 oxide. I will write iron 3 oxide and not the iron 2 oxide, right? So it means that the iron with the oxidation number 3, it is the one that had participated in this compound. Okay. So what we learned so far is how to name the binary ionic compounds, and we learned how to start for the chemical formula, getting the chemical name, or from the chemical name getting the chemical formula, and we also have learned how to do those special ions with the Roman numbers 2 or 3 based on the oxidation number of the other elements. Okay, now the thing is that you have to understand that not all elements okay, so whenever you have a binary ionic compound, you have to understand that this compound is neutral. Now, what does that mean? It means that, for example, if you have sodium plus chlorine minus, then you have sodium chloride. The sodium chloride, or the table salt, that is neutral. That is not plus or minus. It is a neutral compound. So the same thing if I say magnesium chloride MgCl2, magnesium is 2 plus, chlorine is 1 minus, but magnesium chloride is a neutral compound. Okay, so be careful about this because compounds here are neutral. They are not pluses or minuses. Now, so this table is very good to memorize because it gives you the endings of those elements that participate in certain compounds. Oxygen becomes oxide, phosphorus becomes phosphide, nitrogen becomes nitride, and sulfur turns into the sulfide. Okay, now you should know that not all compounds, of course, are binary. Again, we said binary means 2, right? But not all compounds are binary. Now, for example, you have the baking soda, the one that we use to make bread and cakes and so on. That is NaHCO3. So you can see it's not only 2 elements; it's a group of elements that are participating together to make this compound that we call the baking soda. Okay, now I want you to know that there is something called the polyatomic ions. Polyatomic ions, and the word poly means many, right? So polyatomic means many atoms that are combined together to make an ion. Okay, so if I say it's a polyatomic ions, it means many atoms participating together to form an ion. So let's see the definition. It says that the polyatomic ion is a positively or negatively charged covalently bonded group of atoms. Okay, so let's go slowly here. So if I say I have a group of atoms, right? And these group of atoms are combined together covalently, not ionically, right? Remember, covalently means that they share electrons. Nobody is gaining, nobody is losing. It's only covalently bonded. And when they do that, they are not neutral. They are either negative or positive. So it means that they behave like a positive ion or like a negative ion. So they behave like a positive ion or they behave like a like a negative ion. Okay, so we need to be okay. Now if I show you a table, maybe you will understand this more. Like for example, look at this. We have the ammonium, for example. The ammonium is a polyatomic ion, and why? Because it's made up of sodium, of nitrogen and 4 hydrogen. So it's poly because it's 5 atoms, and they are, actually this is positive, this is wrong, this should be positive, this should be plus. It behaves like a plus ion. Now if you guys remember, I told you a few minutes ago that if I speak about sodium chloride, sodium is plus, chlorine is minus, but sodium chloride is neutral, right? But these guys are not like that. These guys are covalently bonded group of atoms, but they are not neutral. They behave as a plus or minus. Now look at the phosphate. The phosphate is PO4 3 minus, so it means it's a 1 phosphorus, 4 oxygen, and they behave like a 3 minus ions, and so on. Okay, now let's practice on how we name complex compounds with the polyatomic ions. Now, if you check this one, you may see we need to name ammonium phosphate. Ammonium phosphate. Okay, so if I want to name ammonium phosphate, what I need to do is, again, I will just follow the same method that I have followed before, and this will be finding the chemical name, right? So I have NH4, that is for ammonium, and PO4, that is for the phosphate. Then I need to write the oxidation number, which is 1 plus for the ammonium and 3 minuses for the phosphate. Then I just need to switch. I put the 3 here and the 1 there, so it becomes NH4, and this will be 3, and the PO4, that will be 1, right? So again, I don't write 1, I don't write minuses, so it becomes NH4 and 3 PO4. Now you will notice that I put the 4 between the parentheses here. See, so I put it between brackets, and the reason is because NH4 is the ammonium ion. It's a positive ion, so I don't say N3H12. That's wrong, right? Because NH4 is one thing. It's like a water molecule made up of hydrogen and oxygen, right? But I don't say hydrogen and oxygen. I say a water molecule, right? The same thing for those polyatomic ions. They are combined together and they behave like one thing, right? So that's how we name those complex compounds. And I guess the next thing is about the hydrate. And hydrate means that there is a water molecule that is chemically attached to the ion. And one example of that is the cobalt chloride. So when you make a solution out of it, it's called cobalt chloride hexahydrate. It's a cobalt chloride hexahydrate. So this hexa means 6 water molecules that are attached to the cobalt chloride. So whenever you see the word hydrate, it means that some water molecules are chemically attached to the compound. Now there's also one of those very famous compounds that we use in usually in constructions and sometimes we use at home, called the gypsum, and it's used to, like, it comes in the form of a powder. You can buy it from any hardware store. It comes in the form of a powder, and then you mix it with water. It makes this white dough that you can use to fill in gaps and cracks in your house or in your bathroom. And this one is a calcium sulfate dihydrate, right? Or dehydrate. It's a calcium sulfate dehydrate because it has 2 water molecules attached to it. And now finally, I want you to learn how to name the binary covalent compound. Binary covalent compound. Now we have learned how to name binary ionic compound, but I also want to know how to name binary covalent compound. So binary again means 2, and covalent means they have a covalent bond, right? So the bond between them is a covalent bond. So let's see, here we have a nitrogen, oxygen, nitrogen, oxygen, nitrogen, oxygen, nitrogen, oxygen. So if I want to apply the same method I have used before, I will just call this nitrogen oxide, nitrogen oxide, nitrogen oxide, nitrogen oxide. Of course, that doesn't make sense, right? So because these are different molecules, so how can I name them with the same name? So to name those compounds, you need to use this. You can just say dinitrogen monoxide, nitrogen monoxide, nitrogen dioxide, dinitrogen pentoxide. So, maybe I can show you those prefixes. So mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, ipta for 7, and octa for 8. Okay, so again, when you name them, you say dinitrogen monoxide, nitrogen monoxide. So I would not say mononitrogen monoxide, right? So it's just nitrogen monoxide, nitrogen dioxide, dinitrogen pentoxide, and so on. Okay, so that's how we name those binary covalent compound. So I guess that covers all what we need to learn about binary ionic compounds, binary covalent compounds, how we name them, and also how we name the binary ionic compound with those special ions that have more than one oxidation number. And also we have learned how to name the polyatomic ions if they exist in those complex compounds. So I think that's all for this lesson, and thank you so much for paying attention. I look forward to seeing you guys for more lessons on MathScratch. Thank you.